Biology 1, this is your review lesson for replication, transcription, and translation, and to make sure that you have an understanding on how to use the codon chart for making amino acids. We're going to start with replication and remind you that in DNA replication, DNA is copying itself. We're going from DNA to DNA, which means that the old strand is being used as a template to make the new strand of DNA material. And so remember, this is going to happen through complementary base pairing, which means that A is always going to pair up with T and G is always going to pair up with C. So in the old strand, we have thymine, a T, and so in the new strand, we're going to have A, and we have G here, so we're going to have C. We have C here, so we're going to have G. We have T here, so we're going to have A. We have G here, so we're going to have C. Sorry, let me make a correction there. We have A here, so we're going to have T. We have A here, so we're going to have another T. We have A here, so we're going to have another T. We have T here, so we're going to have an A. We have G, so we're going to have C. We have T, so we're going to have A. We have A, so we're going to have T. We have C, so we're going to have G. And we have T, so we're going to have A. So you should be able to notice that we're going from DNA to DNA, and DNA always contains the letter T, which means that that's going to represent thymine. Thymine is the nitrogenous base that is unique to DNA only. So now, once DNA has copied itself, DNA can go through transcription, which means that DNA is giving messenger RNA the code. It's giving it the genetic code or instructions for making proteins. And it's going to do it through complementary base pairing. So what you need to remember is that A is going to always be paired up with U, or adenine is going to pair up with uracil, and guanine is going to do what it always does. It's going to pair up with cytosine, or G is going to pair up with C. So uracil replaces thymine in RNA. So we're going to use the DNA template or strand of genetic material to create the messenger RNA strand. And so A is the first nitrogenous base in the DNA strand. So now U is going to be the first nitrogenous base in the messenger RNA strand. We have C, so this is going to be G. We have G, so this is going to be C. We have A, so this is going to be U. We have C, so this is going to be G. This is T, so this is going to be A. We have T, so this is going to be A. We have another T, so this is going to be A. We have A, so this is going to be U. We have C, so this is going to be G. We have A, so this is going to be U. We have T, so this is going to be A. We have G, so this is going to be C. And this is A, so this is going to be U. So you should be able to see the difference between DNA and messenger RNA right away, because DNA has the T, the strand of DNA has the T representing thymine, and messenger RNA has the U representing uracil. So now, once the messenger RNA is created, both replication and transcription take place in the nucleus. The messenger RNA strand is going to leave the nucleus and head to the ribosome. And what's going to happen in the ribosome is messenger RNA is going to send a message to transfer RNA molecules and tell it to bring amino acids. This is where you need to remember that transfer RNA brings the anticodons and amino acids to the ribosomes for the process that we call translation. Translation is the process in which proteins are being made. Where does this happen? Translation happens in the ribosomes. That being said, you need to remember that the messenger RNA molecule carries the genetic code in codons. And codons are groups of 3 nitrogenous bases. So you have 1, 2, 3 nitrogenous bases. That is a group of 3. So for every group of 3 nitrogenous bases, you have a codon. And so transfer RNA brings the anticodons. And those anticodons are actually complementary. They are complementary base pairs in the same fashion that we find in replication and transcription. And so for the first anticodon on transfer RNA, you're going to have A, C, G. So that's the first anticodon on transfer RNA. And then the next anticodon is going to be A, C, U, because this is transfer RNA. So anytime you're dealing with RNA, you're going to have uracil instead of thymine. The next anticodon for the transfer RNA molecule is going to be U, A. And then the next anticodon is going to be C, A, U. And the final one is going to be G and A. And as you can see, we're missing a nitrogenous base, which is going to set you up to understand what we're going to be talking about over the next couple of days, which is going to be mutations. So that being said, translation always happens in the ribosomes. Replication and transcription is always going to happen in the nucleus. So we're still talking about translation. We're talking about the making of proteins. And one of the ways that we decide which amino acids that the messenger RNA is calling for is by using something that we call a codon chart. And so you can see right here, we have the codons from messenger RNA. So whenever determining what amino acids we are calling for, you always use the codons found on messenger RNA. So you can see that I pull the very first codon from the messenger RNA strand that we just created when I just showed you translation. So the way that this works with the codon chart is you have 3 sides. You got side 1, 2, and 3. So each nitrogenous base is assigned to a side of the codon chart. Okay, so we have 1, 2, and 3. So your first nitrogenous base will go, you'll find that along side number 1. So our first nitrogenous base is uracil or U. So we look at side number 1 and find U. Once we have found U, we know that our amino acid is on this row right here. So now we know it's on that row. We're going to find the next nitrogenous base, which is G. So we know that, and we're going to look at side 2 for that. So this is side 2, and this is G. This is G. So we not only know that our amino acid is on this row, it is also in this column. So we pretty much know that our amino acid is going to be in this box. So the third one you need to look for is C. Is C, and that's along this side, the right side of the chart. So we have U, C, A, G, and here is C. So your amino acid is going to be right next to the C in that box. So you know your first amino acid or amino acid is going to be in that row, in that column, in that box. Let's do another one real quick. So we have 3 nitrogenous bases again, 1, 2, and 3. And so our first nitrogenous base is uracil or U, and we know that we look for that very first amino acid on the left-hand side. This is side number 1. So we know again that our amino acid is on this row right here. And so we're in this row, and then we're going to go again to G, okay? To G. So we know again that our amino acid is on this row in this column, and then we're going to find the last nitrogenous base, which is A. So we're right here in this portion of the box for finding your amino acids. Last one. We have 1, 2, 3 nitrogenous bases, which we have our very first one is A. So we go to side number 1 and we find A. So we know that our amino acid is on this row somewhere because we've had to find our first nitrogenous base is A. Our next nitrogenous base is going to be A as well. So we look here at the second, at the top at 2, at side 2, and we find the A. So not only do we know that the nitrogenous base is in the amino acid is in this row, but it's also in this column. And so we know that our amino acid is going to land in this box right here. And so all we have to do is look at side 3 for our final amino acid and mark it where we see the letter U. So that is how you use the codon chart for determining what your amino acids are. You use the messenger RNA strand every time. This is your review on replication and transcription, which takes place in the nucleus, and translation, which takes place in the ribosomes. This is your review on protein synthesis. Thank you. And if you have any questions, reach out to Ms. Piper doing tutoring. Have a great rest of your day.